This session is for OCR FP1. The topic is matrices, and we're going to do June 2011 question 6. And in this question, we're being given a matrix C, which is a 3 by 3 matrix, and we're being asked to find its inverse. So the first thing, in order to find the inverse of a matrix, then the first thing we need to do is to find its determinant. So to find the determinant of a matrix, it's probably just worth reminding ourselves that we need cofactors. And cofactors are minors with these signs attached to them. And what we do when we're finding the determinant of a matrix like this is we expand it. The technique is expanding by either a row or a column. Now it could be any row or any column, but I'm literally just going to take the first row and expand it by that. So we find the determinant by multiplying each cofactor of each entry in that first row by the element itself. So it'll be A times the cofactor of A. Now the cofactor of A, so we cross out the first row and the first column, and the cofactor is the determinant of the little 2 by 2 matrix which is left. So that's 2 times 4 minus 3 times 1, which is 8 minus 3. And that is the first entry and has a positive sign attached to it. And then, well, the next one is going to have a negative sign attached to it. The entry itself is 1. It's in the first row, so we cross that out. It's in the second column, so we cross that out, and we get 4, 1 times 4, minus negative 1, which is 4 plus 1, which is 5. And then the third one would be positive, but it would be a naught. So it really doesn't matter what the cofactor of this third element is, because we'd be multiplying it by 0. So we end up with our determinant is 5a minus 5. And you'll notice that it says that a is not equal to 1, which means that our determinant is not equal to 0, and hence the inverse exists. So now we need to find the inverse. So the inverse of a matrix, what we need to do is we need to find the cofactor of each entry. So we literally take every element, every 9 elements, and we find their cofactor. And then at the end we have to transpose. So the first row, the entries, the cofactors of the first row will become the first column. So I'm going to find the first one, C11. So that is the cofactor of the element in the first row and the first column, which we've already worked out to be 5. It has a plus sign attached to it, so I'm going to put that in. And then I'm going to find the cofactor of C12, but of course that at the end we transpose, so I'm going to write it down here. So I'm going to make my rows into columns right at the beginning. Its sign is a minus sign from up here, and it's in the first row and the second column, so we cross those out and we're left with 1 times 4 minus negative 1 times 1, which is plus 1, so 4 plus 1 is 5. And I'm then going to do the same thing for this third element in our first row, and it is only the cofactor, and we're not multiplying by 0 this time, so we do need to find it. So we're crossing out the first row and the third column, so we'll get 3 minus negative 2, which is 3 plus 2, which is 5. And again, there's a plus sign attached, so we'll put that in there. And then we need to do the same sort of thing. I'm going to do the same thing for the second row. So C21 will have a minus sign attached to it. So we're cancelling out or sort of stroking out the second row and the first column. So you'll end up with the determinant of the 2 by 2 matrix to be 4. And then C2, 2, which is going to be a positive. So in this case we're crossing out the second row and the second column, so we get A times 4 minus nothing, so that's 4A. And then C2, 3. So we're crossing out the second row and the third column. It's a minus sign attached to it, so the second row and the third column, so we're left with minus 3A plus 1. And we'll do the same thing now for the third row. So there's a plus sign attached to it. We cross out the third row and the first column, so it's just going to be a 1. And we have to do this then for each of these. So again, crossing out the third row and the second column, we'll get a minus A. Well, it's an A, but then there's a minus sign attached to it. And then the last one, C3, 3, will be positive, and it turns out to be 2A minus 1. So you need to go through and, as I say, find your 9 cofactors. And this is my suggestion. If you write them down, for the first row, write it down as the first column, and your second row as your second column, then in a sense you're doing all the transposing as you go along. So the inverse of the matrix is 1 over 5A minus 5, and now we can write them down just as they are here. So we have a 5, minus 5 and 5, a minus 4, a 4A, and a minus 3A minus 1. We take the brackets away, and then we have a 1, a minus A, and a 2A minus 1. And that now is our inverse. So there were 7 marks for that question. So if we just have a quick look to see how those 7 marks are given. So 3 marks first of all for the determinant. So you got 1 method mark for expanding it. You got a method mark, another method mark if you got at least one of the 2 by 2 determinants correct, either that one or that one. And then you got an accuracy mark. So 2 method marks and an accuracy mark for getting your determinant correct. When it comes to finding the inverse, then there were 4 marks. So you get a method mark for using the correct sort of process. You get an accuracy mark for at least 4 entries correct in our final matrix. And then you get an accuracy mark for remembering to transpose rows into columns, and a B1 mark for remembering to divide by the determinant. That's for this bit here. So remember that there are plenty more revision videos available by going to the Further Maths Support Programme website and following the link.